Let's talk about the time module. It's a bit confusing that the time module itself has a time module inside it, and now we have another separate time module. This time module can do some other stuff also, and some shared stuff. It can get for you the local time and the date and time components. It can compute differences between times, and this is very important in what we call benchmarking. Benchmarking is mainly used to assess the relative performance of a part of a code. Let's say you have a specific function and you would like to know how fast is this function. So this is an important question. There are like 3 ways to code a function. Yeah, we'll come to that later. There is some flexible functionality in printing. The computed time here is relative, by the way. It is from a starting point we name epoch. So what is epoch? Epoch is a specific date, as we will see, and we compute the time relative to it. Because if I told you that let's say the current time is 10 hours, 10 hours is relative to what? So this is what we call the epoch. It's a very specific starting point, and it is platform dependent. Let's go in details. Here is the time module. The epoch point in the Unix system, for example, is the year 1970, January 1st. So any time you compute a time, you are actually computing, for example, the number of seconds starting from that time. One of the function here is a GMT time, is mainly like converting seconds since the epoch to a time using the UTC or the GMT. So what will this function return? It will compute the number of seconds since 1970 from the 1st of January in 0000 time. I hope you got what is now the epoch and now understand what exactly is the return function of that. The other thing is you can get the local time itself, and this is going to return for you a struct of many elements, and you can get the for example the time of it from the hour perspective. You can access it like an array. So for example 3 would be indexing 0, 1, 2, 3. It will return for you the hour. If you ask it time.time, it's going to return for you the total number of seconds starting from the epoch point. When you write here GMT of time of 0, this is actually referring to the epoch point itself. The time is now referring to this exact time. If you try to make an approximation, we are now in 2021, and from 1970 we have 51 years. 51 years on average 365 days, 24 hours, 60 minutes, 6 seconds. If you multiply all of that together, you will notice it's a bit close to this number. I hope you got the details of that. This is the epoch point. This is the fraction of seconds since this epoch point. And this is the local time with its components. One of the very common functionality in practice is the sleeping functionality. Sometimes you are doing a code, and let's say your code is reading something from a web page or from a database, and you don't want the code to keep doing that in every fraction of second. You might want, okay, I would like to sleep for maybe 5 minutes, then do it again. So to do that, we use the sleep functionality. The way to do that is as following. You call time.sleep and you pass something. This is a total number of seconds. When you write time.sleep 1, it means hang for 1 second. If you give 10, it means hang for 10 seconds. So this is a very useful functionality if you have something like, let's say, every 5 minutes I check my database, every 5 minutes check my database. So the sleep functionality can help me to do this hanging. Now it is useful also to do the time difference, to check the differences and benchmarking that I referred to it in the first slide. So we can do the following. Before starting some function or some block of code, you can get the start time at that moment, and then you get the end time of this moment. The subtraction of both of them will be the time difference. As this code is looping 5 times and we are sleeping almost for 1 second, you will notice the time difference is almost around 5 seconds. This is very useful. In industry, you might have a function, 2 functions, and you don't know which one is really faster. So you might try to do some time estimation for the function to know about the time difference. Now about formatting. We can format a date from a string or the opposite. Let's say we have here the current local time. The arrow function is strftime that can help you to format this time to something in a very, very flexible way. For example, here I wrote I need the time output as following to be number of minutes slash number of days slash hours, then comma, hours, minutes, second. If you give this format, it is going to give you this exact format that you asked it. Maybe someone just need the hours and minutes and second with dashes in between. So hour, minutes, and second, it give you dashes. The M is going to bring only the number of minutes. The C will give it in this format. The S and the R, I forgot what was the S, honestly. And the R is in the time in 24-hour notation. This kind of functionality is also available in the datetime object. There are too many other parameters that we can submit to the strf time function. Feel free to go and read about it, but honestly, most of the time you only need these options. S, by the way, is for the number of seconds. So we have 55 seconds here. So we have S and M and hour. That's all. You don't have to go and read the docs at the now for the more options, because this would be good enough. But I just would like you to know that there are more and more to be passed. The other one is the opposite of that. What if I have formatted the string and I would like to get it back to a date? So let's do that. I here created an object that time and then converted it to a string, which is now this string. Now let's do the reverse. You can use the str_btime to take a string and convert it back to an object. So overall, we have two functionality. The str_btime, which is mainly short for parse time, so it take a time and parse it to object, and the other one is strf_time, which mainly is formatting time. You take a date object and format it. So they are both of them opposite functionalities, and both of them are important in practice. That's all for now.